So in this third example on strings, I'm going to use Mohr circle to solve a problem. And in this problem, what we want to do is we're going to leverage a previous example to calculate the max principal strain. So given the strain field here at the bottom right, 1,750 for epsilon XX and epsilon YY, with a shear of 1,000 each, we would like to determine the max principal strains. That's what this problem statement is. So the first step is to, I'm going to just go here. My advice is to draw you want to draw an arrow first. I'll do my best here. And so that's what I have right now. And what you want to do now, you want to locate two coordinates. The first coordinate you want to locate is so you're going to locate two coordinates. The first coordinate you want to locate is going to be x. So you're going to find x here. And it's going to have coordinates of epsilon x, comma gamma xy divided by 2. And then for y, you're going to locate that. And for y, you need to plot epsilon y, comma, negative gamma xy divided by 2. So that's sort of the process. So for x, what I have is a coordinate of, what do I have? So epsilon x is this one, 1,000. So 1,000. And gamma xy is 1,000, that's 500. And then for y, I have epsilon y, which is 750, while gamma xy divided by 2 is negative 500. You have to remember that sign right there, a negative. And so what I want to do is find those points in here. I would like to find them here. So I will then draw a circle, or not a circle yet, but find the location of where that goes. So I'm going to say that 1,500 is somewhere here. I put a marker here. So what I'll do is I put a marker here. For 1,000. So 1,000 is over here somewhere. So 1,500 is over here somewhere. So I put my X there. Give me a second. All right, so now we have to find Y, which is 750 and has coordinates of minus 500. So that's going to be somewhere. So minus 500 is basically directly opposite, but 750, that'll be, so these 1,000, I'm gonna say 750 somewhere here. So that point is going to be somewhere here. Okay, so that's the first step, and then you draw a line. This point here, Y is 750. minus 500. Okay, so we have that so far. So that's your X and that's your Y. I'll remove these little lines so that they don't bother us for now. But that's how you draw the line X and Y. And so now you're ready to understand that this is the center of where the circle is. So you know that's your radius. So all I have to do now is draw a circle. And I'll draw a circle. And I'll try to make the circle empty. I'm trying to look at the circle the best I can. I'm gonna say probably over here somewhere. That works. That's my circle. Okay. Remembering that the x-axis here is strain, right? And these are shear strain divided by 2. So I have that. So I join X and Y and I drew the circle. So first step is to do this. Second step is to locate it here. The third step is to draw the circle by joining X and Y. And we did that here. We joined it. And where it intersects, that's the center, C. So you can draw a circle very quickly. And you can then quickly calculate the radius of that circle here. That's R. So we know C. You can calculate C very easily, the center, and you calculate the radius very quickly also. You don't need to remember the equations at all, because this distance can be easily calculated by you. Like, for example, you can calculate the distance between these 2 points divided by 2 gives you the radius. So that's a very easy calculation for you to do. So you don't have to memorize anything whatsoever. And the center usually is going to be given by epsilon xx plus epsilon yy divided by 2. In our case, as 1000 plus 750, that's 1750 divided by 2. That'll be close to, say, you know, it's not exactly 900, but it's like 875, say. And you can see here that that's kind of 875 because it is 1000 and that's 750 somewhere in between. So you can see it's working out. And then the radius can be easily calculated as well by finding the distance between these 2 points. I won't do it because it is an easy thing for us to do. So where is the principal strains? The principal strains are going to be this one. That's the maximum value, epsilon 1, and the minimum value, epsilon 2. That's your 2 principal strains. And that can be easily calculated because that's where it intersects the abscissa x-axis, this strain axis. That's where the maximum strain occurs. And where it occurs, where is that maximum strain, principal strain occurring? So first of all, you can notice here that the max principal strain is epsilon 1, the center, whatever is located at, plus R, and the minimum strain is going to be C minus R. By the way, R can be easily calculated. You can do it quickly now with me if you want, but it's going to be 1000 minus 750 squared plus 500 minus 500 squared divided by 2. Because that gives me the distance between these 2 points, divided by 2 gives me the radius. Once I know the center plus the radius gives me this principal strain. The center minus the radius gives me this principal strain. And so I'm able to find the principal strains very quickly. Very, very quickly. So far, as you can see, the process is relatively easy to follow. I'll erase this so we're not confusing anything. And then now the next step is to realize that the max principal strain is given by this angle. And that angle is 2 theta P. And you can calculate that angle very quickly by using trigonometry, which we will not do here, but it can be easy to calculate because you know the coordinates here. And so that allows you to calculate the angle there. That's where the max principal strain occurs. Now, where does the max shear strain occurs? The max shear strain occurs along a dashed line that you draw here. Okay. And is going to occur here and here. So draw a line there, and that's where it occurs. So the max in plane value is going to be this number here that you get right there. Okay, so that's how you do the calculations using Mohr circle.